Greetings and thank you for your time today. My name is Matt Conweiser and I'm one of the QRadar technical leads with IBM located in the New York area. Today I'd like to have a conversation with you about security intelligence. Now, we very intentionally use the term security intelligence for two reasons. First, because QRadar is not just a set of SEM capabilities, and second, because security requires intelligence to be functional. In this case, intelligence is both the ability to rapidly process and learn from the environment, and it's the volume and quantity of information that can be used for security analytics. One of the best discussions I've heard that reinforces the importance of security intelligence for the current enterprise threat landscape was a dialogue at IBM's Think Forum event between Ginny Rometty, CEO of IBM, and Dr. Shirley Ann Jackson, who's a PhD and the president of Rensselaer Polytechnic and also was recently appointed to President Barack Obama's Intelligence Advisory Board. During that dialogue, a three-model process of security was discussed, and those three models were protect, detect, and mitigate. The protect model consists of your traditional security mechanisms, things like antivirus, IPS, firewalls, malware, and other related applications and appliances. The fundamental issue with this model is that it is largely reactive. Each appliance works without connection to the others, and identification of a threat is dependent solely on whether the applications have a set of definitions that match current known threats. In the detect model, there's a shift from the reliance on a collection of more traditional security systems to the aggregation of those into a single security operations center. By bringing all the data sets together and putting eyes on them by a skilled security professional, there's a greater chance of detecting problems as they arise. The development of a process on how to handle problems that will help to speed overall time to identify and remediate is also part of the detect phase. The third model is the most advanced and requires a ground-up approach. Now, the most effective way to create a mitigate environment is to embed that philosophy into each component of the enterprise as it is implemented, but that's not realistic. For many businesses, they've already made such a large move towards protect and detect that there's also a bridge that needs to get crossed. Creating that bridge requires taking the cumulative information from the fundamental security and security operations centers and collecting that, and as many other data points as are available, into a database that has the ability to cognitively process the information being ingested and develop a set of analytics that are meaningful from it. The human-driven processes in the detect model become learning systems that use a combination of pre-built and customized policies that operate on the raw data and analytics that have been collected and developed. Finally, as the system continues to run, it learns, remembers, and adapts, turning millions of data points into a handful of meaningful, legitimate concerns that a small security team can investigate and act on, and ultimately creating a memory cell environment for the security posture of the network. But there's another dynamic to this. It's not just about the three-model system. The other thing to look at is the fact that simple problems, and by that I don't mean simple to solve, just simple to identify and recognize, are now more often than not precursors to more global problems. A good example of this is industry use cases, which are very typically compartmentalized by segment. Let's say instead of starting with finance concern of insider trading, you deconstruct what insider trading means and look for those characteristics across industry boundaries. You'll see the same fundamental use case appear. Now, a hospital wouldn't be trying to detect insider trading any more than a retail establishment would be trying to stop child abduction, but they all have some of the same characteristics. It's difficult for a security operator to extract the properties of every attack vector from any industry and fit them into their own environment. So that's where the mitigation framework comes into play. Cognitive analytics and learning systems will be looking at behavioral issues and anomalous activity and putting names to them, even if a security vendor hasn't named it yet. The bottom line here is that as important as industry use cases are in order to prove value, having a security intelligence platform to help identify issues in your environment, regardless of which industry area a particular issue would be expected to appear in, is essential. I like to use analogies, so let me ask you a question about handling security. If your IT environment were human, how would you diagnose it? So take a look at a typical sick child process. You start with the symptoms, things you can see and how the child feels. In this case, the child is dizzy, has a fever, a cough, a stomach ache, and a headache. The next natural step is to do some further investigation. What does the doctor say? Who from their class is also sick? What have they been immunized against? Where and with who have they been playing? Is anyone else in the family sick? All of these points are valuable information. The same model applies to a server or server farm. They report what they believe to be wrong, and a series of applications, appliances, and diagnostics attempts to report outside observations and indicators that may help to isolate and treat problems. That said, in this model, there are two issues. First, you're only looking at information that's being reported by and about a system that's already affected. And second, the information being collected is a set of opinions provided by fundamental security elements that are for the most part only looking for things they have names for. The reality is that there are hundreds to thousands of data points that are all feeding into the data center and fundamental security infrastructure that are more important to assess and collect from to truly understand the security posture of the environment. It's important to collect as many of these data points as possible and classify them into trait groups so they can be watched for abnormal behavior or patterns of change that would indicate an attempted attack. When you're gathering large amounts of environmental intelligence, it's possible to create better security for your business. In short, big data and security are partners. And if you believe this to be too aggressive an approach for your business, just think about this. Are you more concerned about known or unknown threats? Now, I hope your answer was unknown. Known threats are things that you can already see coming. You may not know when it will happen, but you know what it looks like, where it's headed, and the objective. Unknown threats are traditionally not detected until it's too late. Whether or not you're convinced or still not sold on this idea, here's 3 simple questions to reinforce the point. First, how accurate are the symptoms only reported from affected elements? Can you trust a child with a fever to know if the room they're in is cold? The truth is that no, you cannot trust an affected system to tell what's wrong. Second, are symptoms and diagnostic data enough to isolate unknown threats? Again, the answer is no. Diagnostics and fundamental security information, along with symptoms from affected servers, will not be able to pinpoint unknown attack vectors, especially when those vectors bypass workstation and server safeguarding. And third, can you predict what sources to collect data from in order to detect new threats? Once again, the answer is no. Hackers are becoming more sophisticated and exploits are originating from a wide variety of sources. The best chance for early detection, or in some cases any detection, is to use big data collection and analytics in conjunction with true security intelligence to develop a complete view of the environment you're attempting to protect. Gartner agrees with IBM's strategy as well. That's why we're typically in the top left of their Magic Quadrant. This only looks at SEMs, and QRadar is not a SEM, and therefore focuses only on the SEM portion of QRadar's capabilities. It's my opinion that if Gartner included the complete QRadar security intelligence platform, we'd be off the chart. But editorials aside, there are 2 attributes which are very relevant to building a broader view of enterprise security that Gartner specifically recognized us for. First is the inclusion of flows, deep packet inspection, and behavioral analysis to create a complete picture. And second is the ease and simplicity, as reported by QRadar customers, of both deploying and maintaining our system. It is possible to explain why Gartner ranks us the way they did, the difference between a SEM and QRadar, and why so many businesses believe great security is a complex undertaking in a simple set of visuals. In a traditional SOC model, there are typically a collection of security appliances that ingest logs, events, and flows. There may also be appliances that review vulnerability, threat, and patch data. Some may have a configuration analysis and audit tool. Finally, there may be a packet collector in the event a more detailed analysis is required. Each of these filter their information on a set of rules, producing alerts. A traditional SEM is only logs and events, and depending upon the platform, varying degrees of support for network activity or flows. These alerts that they all produce are now reviewed by an operator, visually correlating the information and using that to determine the potential risks to the security posture. That operator will next feed information into an IT ticketing system, send out notifications, hand off incidents to different operators, and finally run and deliver reports to key individuals. Lastly, when or if required, an investigation can be manually created using a forensics tool with the information gathered by the packet collector. All in all, this is a complex multi-tier model that can involve a multitude of vendors and can be a victim of both human and machine latency. SOC operators can spend hours sifting through thousands of alerts that may be benign, or if not correlated across every appliance, may not be a good indicator of the true threat at hand. Now let's compare the multi-tier, multi-vendor SOC model to the QRadar security intelligence model. Everything represented on this page is part of the QRadar system. No third-party vendors or multiple management interfaces. We start with the same security elements, each with their own set of rules, but we add the ability to create compound rules as well, which begin to formulate connections between similar activity based on origin, destination, and timing. That information is fed into a correlation engine which groups similar issues and produces a streamlined set of offenses. Those offenses are then fed into a set of engines that can automatically hand off to ticketing systems, deliver notifications, and run any number of reports that are built into the base system. In addition, if a forensic investigation is required, the system can use the compound rules and correlated offenses to automatically initiate an investigation by querying the packet collection element for the associated data sets and sending it to the forensics engine. No human latency, minimal machine latency, near total automation, and all under a single management and administration interface. QRadar Security Intelligence is not a SEM. Going back to the Gartner report that indicated our customers find this system relatively easy to deploy and manage, this is a simple representation of how QRadar gets deployed. The system is installed and licensed, and all of the information sources are pointed at it. The system will automatically detect the type of source coming in, and it will begin using that for rule matching, correlation, and offense and report creation. The system will learn baseline activity types and levels and will, in as little as 24 hours, create valuable dashboards and insight to your environment with little or no user intervention. From that point, it is about customization of the system and acting upon the insight that is being produced. Even with this much simplified model, many customers still desire or require supplemental support from a managed SOC, but not all offers are created equal, and not all specific services are suited for all situations. Many managed SOCs use multi-tenancy for cloud-based deployments. SEMs configured for multi-tenancy can often have decreased functionality, but I'm not going to drill down on that now. What I want to focus on is how and where the information required to produce offenses gets collected. In the first scenario, the processors and database sit in the MSOC cloud. I want to emphasize that I'm talking about processors and not collectors. Collectors are designed for offline storage, and as the name implies, are only collecting information to be forwarded on. QRadar bases its architecture off of processors. The distinction is that each processor, as part of a QRadar deployment, collects, normalizes, stores, and runs queries on the information being received. The more processors you have, the larger the database storage capacity, and the more powerful the query engine becomes. With the processors in the cloud, all of the raw data must be sent to the cloud. While this is fine for events and logs, the more sensitive the information is, the greater the risk of exposure becomes. In addition, for packet capture, flows, and vulnerability data, it becomes increasingly cost and complexity prohibitive to effectively send this information. If you limit the data sent only to logs and events because the managed service cannot accept more feeds or put processors on your premise, you go back to the traditional reactive model of protect, using a SEM as a glorified log manager. If you move the processors and database into the customer's network, the MSOC can still quite effectively monitor and manage the environment, but without the risk and limitations of the previous model. There's also greater long-term flexibility with a shorter migration ramp should the customer need to switch managed providers or decide in time to take over management of the security platform. In addition, it is possible to take advantage of full network activity analysis and packet capture where appropriate. All in all, even with a managed service where the customer may be less concerned about the details behind the scenes, it is important to understand not all architectures are the same and take the time to analyze the differences between the platforms being used, the method of service, and the long-term migration options. In order to cleanly summarize everything I've discussed so far, here are 4 key points I want you to take away from this session. First, you cannot create effective security without the ability to ingest any data source, regardless of whether you believe it is security related. Second, unknown threats are far more dangerous. You never know where they're coming from or what they'll do. And third, it's impossible to ingest every data source and isolate and rate unknown threats unless the security system is capable of managing and correlating all sources, monitoring behaviors and external information, rapidly configurable and dynamic with fast overall time to value, and located optimally for traffic management and risk containment. Now, this may seem like a bit of a panacea, but I believe that actions always speak louder than words and charts, and so at this point I would absolutely encourage you to have a demonstration of this product or do a proof of technology or a proof of concept. Put it in, see what it can do, and understand that it really is as simple and as comprehensive as it's being described today. And with that, I'd like to thank you very much for your time and listening and looking at this presentation. I hope it's been interesting and informative, and I absolutely encourage any feedback or contact if you care to reach out to me. Thank you very much again, and have a great day.